In this video we will add and subtract vectors, including vectors that are multiplied by a scalar. A scalar is a number that is multiplying a vector. So let's start with u plus v. Now problem number 3 here is going to seem pretty silly because vector v is vector 0, 0, which is invisible because it has a magnitude of 0. So really, I'm only going to be dealing with vector u. I'm really not going to do anything with vector v because it's not really there. So, as I graph vector u, that's negative 5, 3. So in standard position, I would go left 5, let's see, 3, 4, 5, and then up 3. So here's vector u. I'm going to go ahead and make it blue. And now I would normally go ahead and graph vector v, but it's over nothing, up nothing, so you're not going to be able to see vector v. Which means that this vector u is actually the solution. There's nothing more for me to do. In fact, I usually make the solution green, so in honor of that I'm going to switch this to a green vector because it is also the resultant vector. If I were to show this silly little problem algebraically, I would do vector u, that's negative 5, 3, plus vector v, 0, 0. Adding the corresponding components, I'm going to get, oh look, negative 5, 3. Alright, which is the same as vector u. So that's going to sort of happen over and over again. If I wanted to do u minus v, it would be the exact same thing. I would start by graphing vector u, which would be negative 5, 3. And normally I would also graph vector v. But in this case, because vector v is 0, 0, there's really nothing for me to graph, and voila, that's the solution. And again, if I try to do this algebraically, negative 5, 3 minus 0, 0, that's just going to leave negative 5, 3, same as before. Okay, so this problem feels a little bit silly. Anyway, let's just follow through. Now let's do 2u. Okay, so vector u again is negative 5, 3. So this is negative 5, 3. Okay, so that's vector u so far, but we want 2u. So what I will do is I will select it. I'm going to copy it into memory, Control C. I'm going to click way over here, and I will do Control V to paste it. Okay, so now I've made a duplicate copy, which I can drag okay, it's sort of running into the other problem, but anyway, look, that is what 2u would look like. And then now normally I would graph 3v, but again, because vector v is 0, 0, 3v is still 0, 0. So really this is going to just be my final answer. And algebraically, if I do 2u, that's 2 times negative 5, 3 minus 3v. Okay, so multiplying the first vector by 2, that's going to give me negative 10, 6. Okay, multiplying the second vector by negative 3, it's just going to be 0, 0, which is just going to leave me with negative 10, 6. So this should be 2u minus 3v, and it should be left 10 and up 6, which is exactly what we have. Okay, so it's going to be the same thing for number 4. Again, we're dealing with a 0 vector, so it's going to feel a little bit silly. If I want to add vector u plus vector v, but vector u is the 0 vector, then all I'm really going to have is vector v. So I'm just going to go ahead and graph vector v and call it a day. 2, 1. So over 2, up 1, boom! That's the sum of vector 0 and vector v. And of course, if I did this algebraically, 0 plus 2 is 2, and 0 plus 1 is 1. Okay, so there you go. Same thing if I want to subtract. Well, okay, sort of. Really, I guess the best way to do this is if I'm going to do u minus v, but if vector u is the 0 vector, it's kind of like it's not even there. So what I'm left with is negative vector v. That's the opposite of vector v. So look, right here I already have a copy of vector v. If I can grab it. So I'm going to copy it and paste it. So here is a duplicate copy. So this is vector v. Now, I want the opposite of vector v because that's what's left. And I can do that digitally by rotating. So, here I am under the draw menu, and I'm just going to rotate 90 degrees twice. And now I have the opposite of vector v. So in fact, I think I should change the color to purple. Alright, that's what I use when I have the opposite of a vector. So this is the opposite of vector v, so I can just bring it over here and graph it, and boom, there it is, opposite of vector v. And that's it. And it's the same thing here. 0 minus 2 is going to be negative 2. 0 minus 1 is going to be negative 1. And looking at our little vector here, sure enough, it goes left 2, down 1, just like one would think. Alright, last but not least, 2u minus 3v. Because vector u is 0, 0, when I graph this, there's going to be nothing to graph. 2 times nothing is nothing. So what I'm really graphing is negative 3v. And look, here I have a copy of negative v. So I'm going to Control C, copy that into memory, and Control V, paste it. So now I've got my own copy. Alright, so this is vector v. Well, negative v. But look, we want negative 3v. So I actually need to duplicate this 3 times. Okay, so I'm going to copy it again, and I'm going to paste it 2 more times. Okay, and so I'll just put those end to end. So that's how you get negative 3v. And there it is, graphically, there is negative 3v. It's 3 negative v's. So, if I were to do this algebraically, 2 times 0 is 0. Alright, if I multiply this vector by negative 3, that's going to give me negative 6, comma, negative 3. 0 plus anything you can really just ignore the 0 and just keep the other vector, so negative 6 comma negative 3. Alright, and so let's compare that to what we got graphically. And in fact, this resultant vector does go 6 to the left and 3 down, so it matches. Alright guys, that's going to do it for this video. I hope it was helpful, and I will see you on the next video.